Hello, everyone. We're going to be finishing up our right triangle unit with talking with angles of elevation and angle of depression. And so these are the real world problems that are being applied using trigonometry. And so when we talk about angle of depression and angle of elevation, it has to do with your perspective. So if I am a person, I'll be a red person, and I'm looking up, that means that's going to be my angle elevation. So we're going to be working with, so we're going to be looking up. And it's kind of going essentially with your, if you want to think about it, you're elevating your eyesight. Angle of depression is when you're up somewhere, maybe on top of a building, let's say the Empire State Building, and you are looking down. You're looking down. And so what's kind of interesting about the angle of depression and the angle of elevation, they end up actually being equivalent. And so they're actually going to be congruent. And the question is, why? Well, if I have the ground, and I'll highlight it in green here, and I have a line of sight that's also horizontal, way above on this building, I have two lines that are parallel. Well, if I have two lines that are parallel, then I could have a transversal. So there's our little backward Z, or sorry, backward Z, where my alternate interior angles are going to be congruent. So the angle of elevation and the angle of depression are actually going to be the same. And so maybe that might be a little bit easier for you if you want to always think about in terms of elevation. You can identify that angle, and then put it on as an elevation versus depression. Okay. And so if I have this little picture here, up here, this will be my, whoops, that is not what I wanted. Undo. Here we go. So this will be my angle of depression because I'm looking down. And then over here will be my angle of elevation because I'm looking up. Alrighty. So let's go ahead and flip to the next page. Okay. So first working with elevation. So when you're doing this, you want to first draw a picture. So at a point on the ground, 39 feet from the foot of a tree, the measure of the angle of elevation to the top of the tree is 42 degrees. Find the height of the tree to the nearest foot. All right, so I have a tree. Don't make fun of my tree too much, okay? Okay, there's my tree. I have no idea how tall my tree is. But I do know that the distance from my tree is going to be 39 feet. And that if I look at the top of the tree, my angle measure is going to be 42 degrees. And so I'm going to be using sine, cosine, and tangent to be able to help me solve this. So we're using our trig functions. Here's essentially a word problem going along with trig. And so remember, when we're talking about trigonometry, we're going to be using our SOHCAHTOA. So sine is opposite over hypotenuse. Ka, like you're driving a car, is adjacent over hypotenuse. And finally, TOA. Tangent is going to be opposite over adjacent. And so I'm curious, which ones do I have? Here's my theta. It's 42 degrees. Okay, across from theta is going to be the height of my tree. So that's going to be the opposite. So I'll label that as OPP. Okay, across from here's my little 90-degree angle. Here's my hypotenuse. There's nothing there. And then next to my theta, I have horizontally 39 feet. That's going to be my adjacent. And so I have an O and an A. And so I'm looking for an OA, so that means I'm going to be working with TOA. So tangent, excuse me, of my angle measure. In this case, my angle measure is going to be 42 degrees. Is going to be my opposite length. Well, my opposite length, I don't know, so I'm going to use X over my adjacent length, which is 39. And so I'm going to first solve for tangent of 42. And so make sure you're in degrees, but when you put in your calculator, tangent of 42 is about 0.9. So 0.900 dot, 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 is equal to x over 39. So in order to solve for x, I need to multiply 0.900 blah, 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 the rest of the number times 39. So when I do that, I get 35.115. So we're talking about they want us to round to the nearest foot. Okay, so we're talking about 35 feet, which is pretty reasonable for the height of a tree. Alrighty, moving on to the next one. A ramp is 60 feet long. It rises a vertical distance of 8 feet. We want to measure the angle of elevation formed by the ramp. So let's first draw the ramp. So I have a vertical distance of 8 feet. So here's 8 feet. A horizontal distance of 60 feet. And they want us to find the angle of elevation. Well, my angle of elevation is going to be located in this corner right here because I'm going to be looking up. If I'm here, that means I'm looking down. You can kind of see the hypotenuse is going down. If I'm over here, the hypotenuse is looking up. So we're solving for theta to be in that corner right there. Well, theta is always taking a picture of the opposite side. So in this case, my opposite is going to be 8 feet. So I'll put OPP on this side. Okay, next to my theta, this is my adjacent. Okay, so again, I have an O and an A. So on the SOHCAHTOA, this becomes a TOA. So we have tangent of our unknown angle measure is equal to my opposite length, which is 8, over my adjacent length, which is 60. And so again, if I'm solving for an angle measure, I need to get rid of this tan part. That means I need to do the inverse operation. So on your calculator, it looks something like this. You'll have to hit the second button or the shift button or something like that to get that little -1 next to the tan. And your input is going to be that ratio of 8 over 60. And so assuming you're in degrees, you set that up, you should get, so second tan of 8 over 60 is about 7.5 degrees. I'm just going to go ahead and round that up to 8 degrees. So approximately my theta is about 8, has a rise of 8 degrees. Alrighty, so let's move down to depression. So depression means that we are going to be looking down. I found that most learners seem to translate using equivalents with elevation and depression. And so I'm just going to go ahead and keep on doing that. And so I have a lighthouse. So again, no judgment on my lighthouse here. Okay, and my lighthouse is 65 feet above sea level. So the height here is 165 feet. Ooh, that's an ugly 6. Let me fix that. 65 feet. There we go. And the measure of the angle of depression of a boat at sea is 35 degrees. So that means if I'm standing on the very tippy top of my lighthouse, and here's my little guy, and he's looking, and he's looking down, that means he's looking down at a value of 35 degrees. I have found a lot of learners get very confused. They'll put the 35 in this corner right here and not in this one right here. That's why I like to move this 35 down here. Since these angles are equivalent, I'd rather you guys kind of think of it that way. So if you see the angle of depression, just go ahead and fill it in and create an angle of elevation. So the guy looking down is 35 degrees. If I'm looking on a boat, so here's my little boat. He's looking up also at 35 degrees. And so we want to find the nearest foot, the distance from the boat to the lighthouse. So this part right here, we just don't know. And so I'm going to focus in and I'll highlight in blue the triangle that I'm going to be working with. And so that I have 35 degrees, I have 165 feet, and then an unknown. And so here is my opposite side. Whoops, that is totally not a pen. I keep doing that. Here's my opposite side. Here's my theta. Here's my adjacent side. That's my unknown. And so again, an O and A is going to be that TOA. So we're talking tangent. So tangent of my angle measure 35 is equal to opposite 165 over my unknown. And so on my previous video, I talked about how if my variable's in the denominator, what I like to do is to use the idea of cross products. And so tangent of 35 is the same thing as putting it over 1 and then using cross products. So I have x times tangent of 35 degrees is equal to 1 times 165, so 165. If I'm solving for x, I can do 165 divided by tangent of 35. And so then I get around 236 feet approximately. Okay. Alrighty, moving on to my challenge question. So I have a pilot who is flying an altitude of 12,000 feet, and he spots 2 airports directly in front of him. The angle of elevation from one airport to the plane is 78 degrees, and the angle of elevation from the second airport is 19 degrees to the nearest foot. What's the distance between the 2 airports? Alrighty, so here's my plane. Again, don't judge. Okay. And we have a couple triangles. We have one triangle here. So that's my furthest airport. And he is 12,000 feet in the air. And that first airport, my furthest airport is 19 degrees. I'll just do 19 degrees here. He spots a closer airport right here. So again, here's our right angle. This is 78 degrees. And so they want us to find what's the distance between them. Put a question mark right there. Well, what I could do is if I find the length of this whole big black one right here, using SOHCAHTOA, and then I find the length of the blue one here, again using SOHCAHTOA, couldn't I subtract the bigger one from the smaller one to get this little bitty part right here? And so in order to set these up, I'm going to identify my thetas. They're kind of both working on the same value. And so here's my opposite side, that 12,000 feet. And then we're going to be working with adjacents. So both of those are going to be the adjacent. So I'm going to try to keep these color-coded. So let me do the one in black first. So again, we're talking about tangent. So tangent of 19 degrees is equal to opposite. Okay. Over adjacent. So I'm just going to put, I'll put an X here initially, the bigger one. And so again, we're doing the cross products. So X is going to be 12,000 feet divided by tangent of 19. So what I really did was X times tangent of 19 is equal to 12,000. And then divided by both sides by tangent of 19. And I get 34,851 feet. So that's the length of that full black one from here to here. All right, so now let's do our blue one. So tangent of 78 is equal to 12,000. I'm just going to go ahead and make that a Y. It's an ugly Y. Sorry about that. There we go. And so using the same idea of cross products, I have 12,000 over tangent of 78. And so that gives me about 2,551 feet. And so now I can subtract the two. So I'm going to take 34,851 and subtract that from, or subtract rather, 2,551 feet. And I get about 32,300 feet. And so again, that's a challenge question. All right. Hopefully this will help you out a little bit as you complete your assignments. Feel free to contact me during office hours. See ya.